Because if I pull up, that charger better be working.
That is a fantastic holster, cable, and connector right there. And pretty much any one of our viewers who has an EV probably has some Eaton in their vehicle.
Yeah.
What we're most interested in is hundreds of kilowatts or centralized, or what I would call bulk charging.
Hello, good morning, and welcome to another Out of Spec Reviews video, and welcome to Pittsburgh, Pennsylvania. Why am I in Pittsburgh? Well, our friends at Eaton invited me here to their experience center. I'm sure you're familiar with Eaton as a company. They provide grid scale electrical solutions all the way down to home breaker switches. So why the heck are we here? Well, they are actually having an expanding line of EV charging products, both on AC and DC. I wanted to come take a look at them. But the reason I came now was actually, we filmed a video not too long ago about the LA or Southern California charging problem. Maybe some of you saw that, where I waited hours to charge a car in a line. And I'm like, look, we need to find some real solutions that are available today to help alleviate stress on DC charging in urban environments. So that means, yes, more DC chargers, which we'll be discussing Eaton's solutions, but more importantly, more level 2 AC charging. It's something that I keep saying we don't cover enough. So I came all the way here to talk about Eaton's solutions, one of them being behind me, which is perfect for apartment complexes, condos, workplace charging. It's really cool. So we're talking all about charging solutions in this video. On top of that, we'll be talking a little bit about the software that can run chargers and the grid integration, some microgrid stuff with battery storage and solar and some other really cool technologies. And I'll show you some of the eye candy inside their experience center, some of the grid scale, the 33,000 volt area. I mean, it's just amazing, some of the things in there, because we're all nerds and we like to see big, heavy power equipment. So join me for a tour of Eaton's charging products here at their Experience Center in Pittsburgh. So we haven't even gone inside. We're just in the parking lot. My friend Brandon joins me behind the camera, and huge thank you to him to fly out all the way to join me. I'll leave his channel linked in the description below. Shout out to TeslaFlex. There are so many different technologies here. We're standing next to a windmill right here, which is like a vertical windmill situation. Any sort of power application, storage, distribution method is inside this relatively large building. And we're of course going to be focusing on some AC charging. So I just want to show you guys over here very quickly. These are a bunch of level 2 EVSEs. But you'll notice there's no like wall box or anything, because these are directly fed from the breaker. And of course, every charging box gives you some indications. Because there's not one, they've built it into the freaking handle. It just helps with theft. There's so many benefits. And so we'll be meeting with the product designers, the engineers of these types of solutions. And this is really perfect for workplace and apartment charging. And they've built it under a solar canopy, which is just amazing. On top of that, they have more traditional EVSEs, of course, AC up to 80 amps, 19.2 kilowatts, which is just, everyone has products like these. This is nothing entirely special. It's just their take on it, but just a durable, hard-wearing, hard-lasting 80 amp box right here. More importantly to me, because I'm a DC charging nerd, they also have brand new high power charging equipment that is modular. So they'll have different power levels, and this Rivian we've drained down so we can test it out and charge it. It'll be my first time charging on Eaton's DC charging station, which really looking forward to trying this out, seeing how the cables work, all of that stuff. Just a really neat piece of equipment. But this is all cool. We're all used to doing stuff like this. I do want to go a little bit outside our element just because there's some really cool high power stuff in there. And just go on a quick tour of this experience center, because I saw stuff in there that is so expensive, things that I've never been able to get up and close with. I'm talking like 33,000 volt transformers that are like behind closed doors at substations. I thought it'd be cool to at least show you some of this stuff. So let's go in there. Let's run through some nerd electrical stuff. Shout out to Eaton for letting us film all of this, by the way. They are so cool. They're open doors. They shut this whole building down just for us today, so we can make this video for you. This is epic. Let's go in. Guys, you join me with Dan Carnevale, who's responsible for this experience center, and thank you so much for having us out.
Yeah.
This is so cool. I can't wait to show the viewers everything that we're about to see, but roughly, what the heck is this place for?
So
the Power Systems Experience Center, we have one here in Pittsburgh and one in Houston. People call them electrical Disneyland. It's basically like, it's a fun place to learn about electricity, and because you can't see electricity, we kind of show stuff physically, and it's it kind of makes it come to life, because it's really hard to explain, you know, the types of things that we do from behind the scenes, you know, whether it's transformers or circuit breakers and things like that, how we bring the electricity to power. In our case here, we're going to talk about the charging stations, but yeah.
Yeah, and actually before that, maybe we can just run over here, because you have a whole display of conduit size, and you know, to make sure you have the right fill, you have different cables. I mean, this is
so actually inside here, it's interesting. We actually pull out some wires, and we'll show people, like, you know, even the difference between copper and aluminum. And if you grab that, and you know, the physical difference and stuff. Okay, so this takes, you know, twice as much power as this can, but you know, even just trying to bend these things and whatever. So the installers that try to put, you know, these things together, they like to explain to people that it's not always physically possible. Well, you know, somebody says, "Oh, just throw this thing in there," and they go, "Nah, it's not quite that way." So this is an example of just showing all the different wire sizes and stuff. So when you talk about a 60 amp charger or a 100 amp charger or whatever, these are the wire sizes that you'd use. And it's just some of the things you have to think about when you're putting.
We discuss DC charging pretty heavily on this channel, where you start getting into, you know, measuring things in MCM. And like big boy stuff, but this, you know, 500 MCM isn't so uncommon to see for a DC charging application.
Not at all, and even, you know, as high as 750 MCM and, you know, 1000 MCM would be, you know, they're going up, because you know, people want more and more power to be able to do things. But this would be typically 600 volt rated insulation, and if you go up to, you know, 1000 volt type cables, you might even see some of these. You see the welding cables and the DLO, diesel locomotive cable. That's the more flexible stuff that you see on the ground and stuff like that for temporary wiring, but you'll see all kinds of different cables and the different conduits and prefab cables and, you know, things like that. So,
I mean, we could do a whole episode just on this wall right here, which would be honestly probably worthwhile, to be like, what type of chargers need what types of cables, and then, you know, eventually I think it'd be cool to run some temporary DC charging off like cam locks on generators, and those are flexible.
Exactly. And that's exactly the diesel locomotive or the welding cable. That would be the cam lock connectors.
So then we also have like a bunch of displays. So the whole experience center roughly is laid out in modules.
So like your home or like a commercial building, or this is, you know, a little bit of a more industrial kind of application. We're rebuilding a room back there where we have, you know, switchgear and stuff, but we'll go in the back room and show you the big boxes.
Yeah,
you know?
here we go.
And then we have the utility overhead lines and stuff. But yeah, it's all set up to be sort of the types of, you know, we think of a power system as being, you know, everything from the utility all the way down to the receptacle in your home. And so as you look through there, all the parts that go together to make that up are the green boxes in front of your house, which would be the transformers.
So we see these everywhere, and it's now a fun game for me to look at the kVA rating of every transformer that I see.
So yeah, so the size, so you might have a 50 kVA transformer, and an interesting thing about that is, so you have 50 kVA, that's 208 amps. You might have a 200 amp panel in your house, but you're sharing that with 6 people.
Sure.
So everybody thinks they have 200 amps, and then you put a charger in at 60 amps in your neighbor, and all of a sudden your lights are getting a little dim and flickering. Those are things that we're talking more and more about just with these things, or whether it's a pole mounted one or whatever.
So even the level 2 home charging in like a neighborhood, a lot of those systems are not built to handle everyone charging at the same time.
No, they're not. And that's, again, it's, you know, if you put solar on your house, you would, you know, call the utility and let them know, and theoretically you're supposed to let them know when you add big loads, but when you start thinking about it, you know, vehicle loads are pretty consistent overnight or whatever, so you might be 8 or 10 hours running that thing, and if your neighbor's doing the same thing, the transformers are going to get a little warm. You know? But, you know, the good news is the utilities are trying to keep up and catch up and make transformers bigger now for neighborhoods so that they don't have to deal with.
And you guys also make transformers as well.
We do. We manufacture transformers, and again, small, medium, and large size. You know, this would be a small 10 or 25 kVA, and then we'd have the pole mounted ones like that would be on the pole there. or we'll see some over here. And then we make the big substation ones too.
Yeah, the big boys. But so transformers, just as at a high level, we're not really discussing too much in this video, but this has been one of the major holdups to EV infrastructure, has been time to get the power equipment in. So my understanding is Eaton's done some big investments on the transformer side.
We have. Well, and that's an important piece. We actually have invested a ton of money into our plants to increase capacity, right? So as you look at, you know, again, there's some on the pole up here.
Yep.
We've got one in the substation over here. And as you look at those transformers, these are the kind of things that people are asking for. And really, we're hearing about neighborhoods that are built.
Yep.
And they're waiting on transformers for a year. So, you know, so the home builders are upset, you know, so you got a lot of people, and the benefit of the transformer again is, you know, like the transformer feeding our whole building, the wire out on the street is like this big.
Wow.
It's about 35 amps of capacity, but inside the building, we need this much copper, and it's 900 amps of capacity. So it's very expensive. We found out during COVID, we bought some of this cable. It was interesting. This was $4 a foot, 600 MCM.
Yeah, yeah.
This was $4 a foot, went to $11 a foot, went to $18 a foot, and then $20 a foot when we were buying it, of course.
Yeah.
And they go, yeah, if you want that price, you got to call back this morning because we're going to give you a new price this afternoon. That's how volatile it was.
Wow. So, I mean, the prices just skyrocketed for anything power related.
Yeah.
And copper went insane. And so this type of transformer, this is crazy. This is stuff that we never get to see. This is like behind the fence at substations.
This would be in a substation, yeah. So there'd be a fence here. This would be gravel. This is a 5,000 kVA transformer. So again, if you look at those, and you mentioned the numbers, that would be 25 kVA.
Yeah. So
or three of them together is 75 kVA.
Yeah.
That would feed like a strip mall or, you know, something like that.
Yeah.
This would feed a whole community and a whole area, you know.
Yeah.
And these ones have liquid cool, and they have fans on the back and radiators.
Cool.
It's just like a vehicle, you know.
Yeah.
And so you have to.
Actually, can we check that out? Can we see some of the fans back here?
Yeah, so you have fans back here, and
that's awesome.
We talk. So this has a dual rating, so you can run it hotter if you have the fans running, and so you'll hear about like slash ratings and stuff. And these things just allow you to do some big stuff in small areas. And we even have some like this one that has a circuit breaker built into it. So this is part of our circuit breakers. It's a vacuum bottle that would be completely enclosed in vacuum. And there's literally a vacuum bottle inside there. And it does the same thing like a normal circuit breaker would do in your home.
Oh, yeah.
So there's all kinds of new technologies, because these things have been around for 100 and some years.
Dang.
But they're still evolving and stuff.
It's cool to see all of this. I mean, just from my perspective, understanding where our energy comes from, where our power comes from, is a lot of stuff like this before it gets to your house. It's really cool.
Right.
But I do want to see some switchgear in there. But on the way, I just want to mention that Eaton, because it's such a huge company with many different arms, also offers components for vehicles. So there's a whole vehicle division.
Yeah, there's a whole, so Eaton has an electrical group and an industrial group, and under the industrial group, Mark can give you some more details about it. We have the vehicle group and aerospace and e-mobility and those parts. But yeah, we do supply a lot of components for vehicles. And it's funny because I'll be wearing my Eaton shirt, you know, and I'll go into a convenience store or something, and they're like, oh, I have a, you know, locking differential on my truck, and I'm like, oh yeah.
That's right. Yeah, you even do superchargers
and stuff. But you kind of think about like how broad we are, and it's a pretty cool kind of company. I you know, around 100,000 people, and we do a lot of different things, you know, globally. So
it's amazing. Yeah. So even this Lightning has some Eaton content in it, which is awesome.
Yeah. So let's go down here, and I'll show you the larger. So we come out of the utility part, we come down through the substation, and then typically we would deliver power to a customer, like that would be, you know, a commercial building or an industrial plant or something like that. And we'll just show you what's kind of on the other side here, the other big gray boxes that we do that are kind of inside. You're welcome.
Yeah, this is stuff that is insane. Like this
it's big, yeah.
I don't even know how much this would cost, but
it gets fairly expensive, and the thing is, it's all about safety, right? So we think about, why do we have circuit breakers in our home or fuses? Is to protect in case something bad happens. So in this case, we have typically, you know, 15,000 volt level, like 13,008, something like that coming in. Here's another transformer, just a different form factor. There's actually radiators and fans on the back of that one too.
Oh, cool.
And then it's close coupled with what we call switchgear. So this switchgear has breakers in it, and these breakers are, you know, very large, you know.
Yeah, holy smokes.
And this is a double wide one, so this is a 4,000 amp breaker. Yeah, it's a big breaker. It weighs probably 350 pounds. There's a couple on a bench over here, but they're, you know, but you're looking at some large circuit breakers, and then what usually feeds that is the medium voltage stuff. So we talk about medium voltage being 1,000 volts to 69,000 volts. This is a piece of switchgear for medium voltage. So like a big stadium or industrial plant or something like that, hospital.
Right. Yeah.
This is actually a circuit breaker, and it's inside the switchgear.
Yep.
And I'll show you what this one looks like here. And
so this is the same thing that's in there.
Yeah. So people don't realize these are actually circuit breakers. And here's that vacuum bottle that we saw over there.
Yeah.
That allows you to put in a very small package. It allows you to clear faults or clear, you know, overloads and stuff. This is 3,000 amps and 15,000 volts. Roughly 25,000 homes would be fed with a breaker like this size. So think about, you know.
How loud is it when it pops though?
This one here is.
We're gonna do it.
Yeah.
That's what I.
So you asked.
Oh damn!
It can be a little loud.
So what's the?
So the winding sound is this little drill motor, and what it has to do is stretch the springs. So if you've ever seen Jurassic Park and the lady's trying to not let the dinosaurs get out, and she's pumping up the breaker, what she's doing is stretching those springs by hand.
Yeah.
So if I do that manually, you know, I can close the breaker, trip it, but what that does is it electronically does it. So now I can do it from 30 miles away or 10 feet away or safely behind a barrier or something like that.
Dang, how cool is stuff like this? So just as a warning to the viewers, I'm fascinated with a lot of these topics, energy, you know, medium, even high voltage applications. I don't know much about this world. I got into this world because of cars, because I like EVs. And we will start an energy channel at some point in the near future. We will come back and do individual pieces on like a lot of, like we could do a whole video on just how the heck this thing works. So that would be epic. So stay tuned for that. We're gonna get into charging now, but that's just a very small fraction of what you guys have here at the Experience Center.
Yeah.
And plenty of videos to come because this is amazing. So thank you for the very brief tour.
Absolutely.
And I know we could spend all day nerding out about this.
Great.
Yeah, I mean, like even just as a topic, you have a whole service center here for.
We do. So these breakers, we call them power circuit breakers. You know, there's a lot of mechanical parts to them, and you saw them over there. But like, as you think about the strings and the arc chutes and things like that, they can rebuild these. So you literally, some of these breakers that we have in the field are on the order of 60 years old, you know, because people build the buildings around this stuff. And then so to replace it, you literally have to knock the walls out. So when you do that, you go, well, okay, is it cheaper just to replace the breaker or whatever? But that's what we do out in the shop here. We have 5 of those around the country.
So yeah, stuff like that and plenty more to come. But thank you so much for that tour.
Absolutely, Kyle. Thanks.
Guys, you joined me with Syed. You're responsible for the AC charging.
That is correct.
Thank you for joining. Appreciate it.
Thank you. Welcome, Kyle.
Thank you.
Again, I'm Sai Murhari. I'm the product manager for AC Level 2 chargers with Neaton, and we're very happy to have you here, Kyle, this morning. And we'd like to show, again, you've seen some of the competencies Eaton has. Again, the focus is on EV charging today, but we'd like to show you EV charging through the lens of power distribution. That's the attempt we're trying to make, kind of give you the bigger picture behind EV charging, you know, some of the things that are probably taken for granted, but the essential stuff. So let's kick it off.
Yeah, so first of all, we started the video out here with this solution, and this product can be installed in a million different ways, but I especially love this under the panel with sort of a you know, bunch of different level 2 EVSEs. We'll get into how that's actually done with the breaker, which is amazing. But so many of our charging problems, our DC charging problems in the urban environments, can be solved with more AC charging. So having apartment complexes, condos, workplace charging available will just relieve the stress from the grid as we're sort of at maximum capacity to build new high power stations. Is that the intent of what this is trying to show?
That is exactly right? So, you know, with so many EV vehicles coming on road and home charging being the primary, you know, means of charging for our EV drivers, we wanted to come out with a solution that can integrate into the power distribution equipment inside your home, right? That is the innovation that we are seeing here. And when you expand that innovation, it can go into panel boards and switchboard in commercial installations, which means parking garages, multifamily dwellings, workplace, and the options are unlimited, right? So the intent is to push EV charging upstream into power distribution and make it more manageable for the grid. That is the whole intent.
Yeah, and this is so important and needed. And just briefly, I'd like to showcase from the user side of this charging solution is you have this handle with lights in it, which I've never seen a connector with lights in it before. Super cool. And you would just plug in a vehicle and it automatically authorizes, or what are the possibilities from the consumer side?
Yeah, it depends on the site host, right? And you're right. Let me touch on the LEDs, right? So Eaton has some intellectual property around this where we put LED indicators into the J1772 handle, because in this case, the EV charger is not to be seen in around, right? It is tucked somewhere inside a load center or a panel board. So the only visual indicator that the EV driver has is the J1772 connector. So we put the LEDs in it to tell them, hey, is the charger available? Is the charger in use, or is there a fault? So that's the intent of the LEDs in the J1772.
And you'll also have a NACS version?
We will be coming out with a NACS version for the same application, meaning with the EV smart breaker chargers we're going to look at. We will be coming out with a NACS version, which will also have the LEDs and the button embedded in it.
Oh, cool. That's going to be neat. So you can open the charge port on a Tesla. Some, certain vehicles, the button doesn't do anything.
Yeah,
but then you'll also have the lights in there. And of course, as we transition to NACS, it'll be really interesting to see what people purchase. And I'm sure more and more NACS as time goes on.
That is right? I mean, some of these transitions may take years, and we are positioned to support both, and we'll be transitioning along with the market. So, I mean, nobody has a crystal ball. We'll have to see what the adoption looks like.
Yeah.
In the meantime, we'll be supporting both.
Okay.
So coming back to your other question about access control and things like that, right? So it's up to the user or the site host on how they want to have these things set up. The way we ship the product, these EV smart breaker chargers, you power them up, they're ready to go. Meaning you can plug it in, they talk to the EV, they start charging. But they can be put on an app and go through a scheduled charging, or they can be put on our Eaton C&M software. That way a site host can provide access control to their tenants or employees or whatever that may be.
Right, so you can have an RFID, or you can say, okay, this is my thing.
For this one, there is no RFID because the charger is tucked away somewhere.
Yeah, good point. Yeah.
So there is a QR code which is on one of the other sites where,
yeah, let's see that actually.
So yeah, so you would commission these chargers and connect them to our Eaton C&M software, and then a QR code would be generated. So a user would come in, scan the QR code, put in their phone number, they would get a code, and then it's a 30-second process to start the charge.
Yeah.
It's not,
but for workplace charging, hopefully they would just give the charging for free. You just plug in and you're good to go.
That is what we are seeing a trend to be. Like, a lot of workplaces are offering free charging. They just want their employees to just put in their email ID so they know that it's only their employees using it. But it's still a free charging at workplace that we are seeing a big trend that's picking up.
And how many amps can these go up to?
This is a 32 amp charger. So the breaker itself is a 40 amp breaker.
Yep.
And the charging capacity is 32 amps right now. That's our first generation, and we are working on our next generation as we speak.
What do you think the next generation will get to?
We're targeting 48 amps, so it's going to be a 60 amp breaker with a 48 amp charging.
Nice. Capacity. I feel like that's the right power level. 32 is totally fine for workplace charging because you'll be there, but for shopping malls and even some overnight stuff with bigger batteries, having 48 amps continuous is awesome.
That is what we are seeing that is the sweet spot. So obviously, when you load up these chargers in a panel board right next to each other, thermals become a challenge. So you want to maintain, or you want to make sure that you're appropriately sizing these and not oversizing them.
So let's talk about how it's wired up, because that's one thing we can show, and that's really the magic. The magic isn't just draping a cable from the ceiling here.
That is correct.
But this is the actual product on the ground right here, so people can get an idea.
That is correct. So, let's simplify the idea, right? If you are a new EV owner, you bought an EV, you want to put EV charging in your garage, you call an electrician, they will have to come in, they will have to put a dedicated circuit breaker in your load center and probably a charger on your wall, and then connect them together, right? So that's your typical exercise that you would do.
Yeah, and I just did one and they charged me $600 to run a wire from my panel to my EVSE, and I'm like, I could just do this myself, but last time I did that, I almost burned down my house, so I'm not going to do that.
Yeah, let's not go there. So we always recommend the use of certified electricians when you do this.
Yeah.
So what we did is you anyway need a circuit breaker to protect your EV charger. So we basically combined those two functions, and this is what that is. So this portion of the piece that you're seeing is a circuit breaker, which is a regular thermal mag circuit breaker, which is 40 amp rated. And to this, we added a couple of additional poles which have Wi-Fi capability built in, which have remote control capabilities built in, and then the J1772 communications built in. So this is a complete EVSE built into the circuit breaker.
It is the coolest thing, because normally we see these big boxes on the wall and you're like, oh, but AC charging really is simple. It is just taking the AC power from the wall to the car with some pulse width modulation in between. And why do we need these big boxes that are incredibly expensive when you can just throw that in your breaker? I've never seen a product like it. It's so cool.
And you're right? I mean, AC chargers are glorified relays in other words, right? So it's basically a relay with a lot of smarts around it, which needs protection behind it. So basically we've been in the business of making circuit protection for 100 years now.
Yeah.
So our philosophy is EV charging, especially AC level 2 EV charging, doesn't have to be these big boxes on the walls and pedestals. It can be part of your power distribution equipment traditionally, right? So that's where this innovation comes from.
It's so cool. So obviously in a home, you would just throw that in the panel, or an electrician would, I would say. And you need to have 4 spaces available, but you can always like combine loads and merge them together perhaps if you don't have that much room.
Again, you're right. This one takes up 4 spaces in your load center. So if you do not have 4 spaces, you can opt for a sub panel and put it in there. So that is the easiest way to do it. And again, and then what we sell is a cord set along with this. So basically these two things put together is what we call a direct connect kit. So the simplest installation is if you have an Eaton load center in your home, pop this in, connect this to this guy, you're ready to go.
Yeah.
And any average electrician, certified electrician can do that, I just
love that. This little thing right here, that's your EVSE.
That is your EVSE. That's exactly what it is.
That is amazing. So, and then, okay, so you would then go into here with your cable. The electrician would hook up, the five connections, and then you're good to go.
You're good to go.
And so 32 amps.
This one is 32 amps. So it's a 40 amp circuit breaker protecting a 32 amp charge. That is right.
Okay, amazing.
And now it's your imagination, right? That's where we started. And we said, hey, we can put it in a load center and you can power your EV in your home. But then, all right, how do we expand on this, right? Load centers are for your home. Panel boards and switch boards that you're seeing here are for more commercial and industrial installations. Now you're talking a parking lot in a multifamily or a workplace. You just expand the idea. Now instead of 1 EV smart breaker charger, you can load up to 10 of them, and that's what we have inside here.
Yeah, let's take a look.
So this is basically one of the Eaton's switchboard, which is our integrated facility switchboard, which does a lot more besides power distribution. It has a transformer also in it, but a smaller version of this is what we call a panel board, which is this portion of it, which has a main breaker up there, and then you have various branches. So what we did here is this parking garage that you're seeing, or the canopy you're seeing, it has about 8 or 10 charging spots, and all of the charging intelligence is in here. So the breaker that we just showed, we have 10 of those right here.
Yep.
So the idea here is if you're a multifamily, all you need to do is you need to get a panel board anyway. If you're thinking of an EV charger, right?
Yeah.
You would get the panel board anyway, and then you need the circuit breakers anyway to protect your EV chargers.
Sure. So it's all stuff you already got to do.
It's stuff you already have to do. Now we just put EV charging also in there, so you're done. So from a cost of installation standpoint, from a total cost of ownership standpoint, this is at least 15 to 20% cheaper when you compare with traditional EV charging. That's what our analysis shows.
So the one thing I'm noticing is cables, my understanding, can't be more than 25 feet long.
That is correct.
But we're looking at much more than that. So how do you get the EVSE from here to an output, let's say, all the way on that end?
That is correct. You got a point there, right? So NEC's Article 625 dictates that the cord set cannot be longer than 25 feet. But the product that we have is the EV Smart Breaker charger with a card set. So we worked with the agencies to get exceptions on some of these things where the EV breaker is stuck in a panel board and the card set can be up to 250 feet away.
Wow.
And we're working on those distances. They can probably go longer in future, but today the limitation is 250 feet, which is quite honestly longer distance.
You have some conduit coming out of here as an example. So let's follow that to the one all the way on the end. And then you've got junction boxes where you have then hooked up the cord set.
That is correct.
And so the EVSE communications can run over 250 feet. There's no loss of
there is no loss. We have tested this pretty rigorously above the ground, under the ground, with water inside the conduit. We have tested all kinds of scenarios, and then we picked that number 250 to be the safe distance where the signals do not get corrupted.
Yeah, okay. So that is really cool.
Yeah,
because the power can run. But
that's the thing, right? So the other advantage of this is you can have your panel board or a switchboard tucked behind a closed fence, locked up, and then you can run wires to a parking spot, and all you have of the exposure off is the card set. So from a vandalism standpoint, you have definitely minimized your exposure to vandalism. So the only thing available is the card sets.
This is one of the coolest EV charging products I've seen in a long time. It just reduces all the complexity of having, traditional boxes and, like you mentioned, vandalism. So many times I've run up and people have either crashed into them with a car. I mean, that's very common.
That is very common.
Or have, maliciously destroyed EVSEs. And really the only thing you have at risk is your cord set, but even if someone just comes and snaps the cable, well, you just order a new cord.
You just order a new one, put it in there. And from a the serviceability aspect of this is also very, very critical to mention. So it's simple circuit breaker. Any electrician that's certified to work on circuit breakers can come in, pop out a circuit breaker, put a new one in, you're ready to go.
Yeah.
You want to add a new one, put one in, and then you run a junction box, and then you're ready to go. So from the serviceability aspect of this is pretty cool too. And one of the other things I'd like to mention is what we're working on is to make this a plug-and-play solution. And what I mean by that is we can configure this whole switchboard or a panel board fully with EV chargers. We can commission it to the back end. We can give you a Wi-Fi hotspot. We can make the whole thing, pre-programmed and ship it to your site.
Right, so you could basically, load it all up, program it here or wherever the manufacturing facility is, and then just go, just install it.
We ship it, and then you power it up, and then it will all connect and be ready to go. So that's what we're working towards getting.
That's cool, because I just had one of the and this is not a knock against this electric company, but I just had a great electric company come install 2 EVSEs in my new house. And it was a 5-day back and forth with support process to try and dial in the whole system, versus it would have been so nice if I could just turn it on and everything worked.
Yeah, right. That's one of the things we're looking at, right, is where are the pain points for the installers. One of the pain points is the electrical installation is probably not the pain point. Commissioning it to the software, getting it connected, that's where the pain point is. These guys don't, a lot of installers, they don't do it on a day-to-day basis. Right? So we want to take that pain out, do all of this in our factory, and get some customer details on what we need to do, and then ship them out so that as soon as they power up, they're ready to go.
Best idea I've ever heard. That's even more exciting, I think. But I also want to just mention, you guys, of course, do the traditional EVSEs.
That is correct.
Up to much higher current, up to the maximum 80 amp, 19.2 kilowatt.
That is correct.
And these products, so can you know the history of Eaton Charging? So Eaton was one of the early days of EV charging, and then I never heard anything, and now you're back.
You're right. So we were in the market probably 12 years ago with our EV chargers. The market was not mature at that time. We came out with a really sophisticated, highly engineered EV charger that the market could take at that time. And there was no scale. The market was not mature, there was no scale. And Eaton's one of those companies, when we get into something, we look for scale. And the reason for us, the reason for us not being able to manufacture a lot of them at scale, we decided to quit the business at that time. And a lot of those chargers are still out there functioning.
Sure, I've seen them.
So they were really well designed, but they were very probably ahead of their time. So Eaton quit the business. We are back in the business. And as you can see now, right, we are investing pretty heavily. If you listen to our quarterly calls from our CEOs, energy transition is a significant piece where we are investing our time and money. And EV charging is an essential element of that energy transition piece. So again, this EV chargers are scaling up, as you can see.
Yeah.
The market's only going up. It may be a slower ramp, but it's going up. So we are here to support that business. Again, not from an EV charging standpoint. Again, we do a lot of things to make the grid more efficient, more safe, and we believe EV chargers are going to become one of the biggest loads on the grid. So we want to be out there putting products out. That way the grid is safe and efficient too.
So these products, just briefly, these are fairly simple 80 amp or 48 amp, you know, 11 kilowatt or 19.2 kilowatt, basically EVSEs, but they're hardy. They've got a nice little light. They've got an e-stop on the side. E-stop's required for high amperage, right?
That is correct. Any charger with a 60 amp or higher require a e-stop that's readily accessible for EV chargers. So that's what it is. So
I wish it wasn't though.
You're right. It's a nuisance, right? It's a nuisance, and we have to deal with it. But it is one of the safety requirements that is by the code making bodies. So we have to comply.
Yeah, totally. So for these types of situations, I mean, this is like you have here. You get a couple high power AC units, but I really think the magic is that over there.
You're right. You're right. So these are the 80 amp chargers that we came out with, and again, like you notice, there's a metal enclosure. You can adjust the output to 32 amps. You know, it has all the bells and whistles a commercial charger requires, right? So it's a traditional box-looking EV charger that can do everything in a commercial sense. So, so we have these products too. But one of the things I want to emphasize is all of these products that we just talked about, either the EV chargers in the load center or the switchboard there, or these EV chargers, these are all connected products. So one of the things when it becomes connected, the emphasis for Eaton is security. And that is cybersecurity, right? We've been in the business of managing power for 100 years. We know how to distribute power safely, right? Safety has been the top priority for us. In the past 20, 25 years, as these things become connected, cybersecurity has become an equally important thing. So that is a thing that's taken for granted, but we take a lot of effort, a lot of emphasis on making these products cyber secure. So with, you know, the stats say that there are 2,000% year-over-year increase in malicious activity to, you know, compromise assets like this. With something like that going on, we cannot be reactive. We are very proactive. So Eaton has a cybersecurity center of excellence. This is an autonomous team within Eaton that has control over all of our connected products, which includes EV chargers. So without their stamp of approval, we cannot launch any products. So we go through a very rigorous cybersecurity assessment right from the start of the product. It's not at the end. It's secure by design. That's our philosophy.
We really haven't seen, and maybe just a few little cyber attacks on EV charging, but as it becomes a much more important part of transportation, and there's so many EVSEs that are cheap on Amazon that are connected, and they're going to be the first ones that are going to fail. I mean, I'm not an expert in this area. I know a lot of our audience is. A lot of them are tech folks. But to me, having that is a really maybe key driver in making a purchasing decision based off what you go for. It
is, right? I mean, you know, like you said, with, you know, the number of EVs on the road, there are a lot of estimates, but, you know, the global demand on electricity because EVs is expected to grow 27% in the next, you know, by in the next 5 years. That means the grid is at risk if these things are not secure, right? And then obviously there is customer information with all of the EV chargers, people coming in and scanning. There's a lot of information that's going from the charger to the back end and whatnot. So for us, making sure the charger is safe, the customer data is safe is of prime importance for us.
So if you had to leave you know, our audience with one impression of Eaton's AC charging, EVSEs all the way to the cables efforts, where do you see the trajectory of your team going? What should we look out for into the future?
It's a statement I already made, right? So we are committed to making safe products, highly reliable products, again with high uptime. I mean, it's a journey. You know, we're on the journey. We're committed to making that journey, making products that are highly connected and provide high uptime, and then secure products, right? So these are the top, you know, KPIs we tend to look for. And then, like I said early on, these, especially AC level 2 charging, doesn't have to be these boxes on the walls or pedestals. They can be integral part of power distribution equipment. And that's what we are going towards, and our focus on innovation is making sure that, you know, we safely upstream AC level 2 charging into power distribution, and look out for more products along those lines.
Amazing. Well, I would say I'm going to plug in a couple cars and just see how they go, because shouldn't be too difficult. We have this Model S Plaid charging here. I'll plug in the Rivian on AC or something,
sure,
just to show it.
It has a QR code, so we may need I may need to scan it and show you. But
sure,
yeah, we can certainly do that.
Amazing. So we'll do it. But thank you so much for the tour.
Yep.
That was really epic. I mean, this solution here with the breakers, not only for home use. Like, I'm just thinking most homes that I've been in, by the way, have like a panel in their garage. So that's awesome. But also for parking garages, the biggest challenge is multi-unit dwelling. If we can have apartment complexes, condos, whatever the situation is, have available and readily accessible level 2 charging, the reliance on DC will just go down significantly, which needs to happen. So epic. Thank you so much.
Thank you, Val.
And just to show you guys the AC charger in use, technically EVSE, but we'll go over here. We'll plug into this Rivian. So we're in. There's a bunch of different access control. You can do it QR code. You can set it up as a free vend, or of course an RFID with a nice Eaton card. And it is requesting to start charging, about to start charging, please wait. Heard it just click. And it even shows you your voltage and amperage and total power delivered, not only in real-time power, but also in the energy delivered over time. And of course, your cost. Everything you would want to know about the charging right there on a simple screen. I'm the first to say it, it's not the most beautiful charger, but it seems pretty hardy and robust, and that's honestly what is most important with charging. So this one's up to 80 amps. The Rivian only has a 48 amp onboard charger, so it's just sitting here right at about 47 amps at the moment. And yeah, there you go. That's charging a car. We've all done it before, but now we've done it on an Eaton unit. And just so you guys can see it, here is the Eaton NACS connector right here. So nice. Man, this is actually way nicer than even their J1772 plug. And it magnetically latches in. That's so cool. So it just pulls itself in as you get closer. And then it's such a nice removal. That is a fantastic holster, cable, and connector right there. Really, really like this. Guys, you joined me with Aiden. Aiden, welcome to the channel.
Thanks, Kyle. Appreciate it.
Thank you for having us. And I mean, you really run like a bunch of stuff for Eaton, and this is the DC charging component is under your umbrella. Roughly, what do your responsibilities entail?
Yeah, so I have a business called Critical Power Solutions. It's one of the bigger divisions in the Americas. Within that, I have 5 business units, one of which is what we call energy transition. So I'm in the power conversion business. So this is clearly power conversion, AC to DC kind of power. And so I actually operate 85% of my business in the data center space.
Oh, cool.
So I'm taking what components I use in a UPS, uninterruptible power supply, and I'm moving those outside. And now I'm charging cars with those. Now I'm converting energy storage, DC power, putting it on the grid. So it's a pretty natural tangent for us inside the data center. So the bulk of the business for us started in a data center, in a UPS mission critical type application.
Similar application, DC charging a car. Yep. Really the components in here are nothing new, but this is the first of many Eaton DC products, I'm sure, to come to integrate with transportation. And what I think is really cool is you coming from such a high level above, of course, even the DC teams, you drive an EV. This is your awesome R1T.
Yes, it is.
We're big Rivian fans over here. So quad motor, Ocean Coast, Rivian Blue, great spec with the all-terrains, love it. And to me, and we were just discussing this, as an EV driver, there's so many people in our industry of charging that actually don't drive an electric car, and they're just selling chargers, but you literally drive one, and you know how important it is that DC charging works. So maybe you can just touch on that a little bit, like, how are you guiding the team to make reliability like the most important thing?
Yeah, I mean, it's the world we live in my division specifically. We call it critical power because of that. We also use the term mission critical. So you can think about where places in a power system where you don't want to lose power or can't afford to lose power. So MRI machine inside of a hospital is an application for what we do with an uninterruptible power supply. Data center customers for us on average lose $450,000 an hour. So they'll pay for us to make sure that their equipment is online all the time. So with my hardware side of stuff, I also have a service business, mission critical service business with a 2, 4, 8 hour service level agreement. To make sure that when we go out there, we leave and that unit is back online. And if you take that outdoors and you put it in an EV charging application, as adoption goes up, mission criticality for us strikes home that says, if I pull up, that charger better be working. And I've driven a number of long distance trips and had those chargers not working.
We've all been there.
So making sure that what we call first time fix, when we leave the site, it's fixed when I drive away. And right now inside of a data center, you know, we have north of 75% first time fix for customers, which is a good rate for them. And they're looking at us going, hey, I know when you show up and then you leave, my equipment's gonna be back online.
Yeah, amazing.
So, yeah.
So this charger right here, obviously this is the first product of many DC products to come.
Correct.
150 kilowatt DC charger.
Yep.
Reliability being the #1 goal here.
Yep.
But also that SLA that you mentioned, having trucks, Eaton trucks, with, you know, parts of this charger on hand that, you know, someone could purchase, a CPO could purchase a 2-hour maximum fix time.
Yep.
That's really cool and almost unheard of in our business.
Yeah.
A lot of CPOs. There's a few that of charging manufacturers that have SLAs that can go around.
Yep.
I don't think I know of one that's 2 hours.
Yeah.
There might be one, but very, very few.
Yeah.
So how does that tie in with the rest of the data center business? That seems like a natural fit.
Yeah, it's a natural fit for us. I mean, when you operate in the data center business, you have to have a service organization that responds like that. You're built differently. It's more of an insurance policy than anything. It's not necessarily a labor hour kind of service business. So our people are paid by these contracts to sit and wait for the phone to ring.
Yep.
We utilize them in other ways, obviously, but the other piece is that carrying of inventory. We only work on our stuff, which gives us the ability to carry inventory on a truck or van and make sure that when we go out there, we have the parts necessary to get it back online. And we're taking that into the charging space and into the energy storage space, and we think it's going to be a big differentiator. As an EV driver, I think it's going to be a huge differentiator.
Yeah, it's cool. I mean, to me, that's pretty awesome. I've never actually seen one of these in use, so I'd like to get your Rivian charging if you don't mind.
Yeah.
So I'll grab the cable, and here you're using air-cooled cables. You know, don't need liquid cooling at this power level. But the future of Eaton DC charging, you think will go up in power?
The future of Eaton.
Oh, maybe the truck is. Brandon, if you just open and cycle the door, I think we let it sit a minute too long. There you go. And Rivian, there we go. It's not your charger that's breaking. It's the truck. Just joking. All right, in we go. Done that many times. And then there's a RFID. You can also have it set up in plug and charge and many different back-end software activations. So once it goes through the connecting process, all typical DC things, says tap card. Requesting authentication, and then there we go, about to start charging. Damn, I'm excited to hear this thing go. So contactors are moving, fans are on. Typical communication times, nothing unusual. Another contactor just went probably for cable check. And I hear some more fans kicking on for, I'm guessing, the power modules, and there we go, we're charging. So what's so cool is it'll actually show you the voltage, which most DC chargers won't. So we're at 420 volts, 62% state of charge. We're ripping 50 kilowatts and it's going. Of course, the Rivian probably won't get up to 150 kilowatts at 62%. Maybe it will. But I just love that you get volts and amps, and it's everything we want. Yeah, 130 kilowatts right there. That's where it wants to settle in, 300 amps or so. Love to see it. So yeah, maybe we can talk just briefly, high level. What's the future of DC with Eaton?
Yeah, so I would say the future of DC, I mean, we believe in wall box charging, we believe in standalone charging, but for us, what we're most interested in is hundreds of kilowatts or centralized, or what I would call bulk charging. So the power conversion is done inside of one box, going out to a dispenser, very similar to a Tesla charging site.
Yeah. So, Aidan, thank you so much for joining. It really was great meeting you and learning a bit. It was just a happy coincidence that you were here today to talk about some DC, and hopefully we'll get to meet some of your colleagues, some of your teammates that are really, you know, deep into the weeds on this stuff as more DC products come. But I'm really glad that the helm of the ship in this area is an EV driver, a really cool EV driver. And you know, you totally get what we care about. So to me, that is awesome to see the trajectory. So thanks for taking the time.
Awesome. Of course, Cal, thank you.
Guys, AC charging is continuing because there's a product called Busway EV charging from Eaton, and it's an indoor fleet application. And actually, just briefly, you can see we have cables coming down from above charging their F-150 Lightning. So Saeed, welcome back. And yeah, maybe you could walk us through busway in general, because this is something a lot of buildings already have.
Right, you're right, Kyle. So before we jump into the actual EV charging busway of it, for the sake of audience who may not be too familiar with busway, I'll quickly talk about what this busway is. Busway is it's a prefabricated power distribution equipment that we have, right? So this is a very efficient alternate to cables and conduits. So what you see here is what we call a feeder, which has the conductors built in, if you see. So the line 1, line 2, line 3, and neutral, and in some instances ground, are completely prefabricated into this compact enclosure, and this is what we call a feeder. So this can go as long as you want. They come in 10-foot sections, and you can keep adding them. What we also provide to users is right angle connectors, T-junctions. So it's basically like Legos. So we give you all the pieces that you can put together to create a busway to distribute power as long as you want and as many directions as you want to split power. So that's basically what a busway is. And what you see here is what we call a tap-off point. So as you're distributing power, whenever you need to drop a power point to a certain location, you plug a bus plug into this location. So this can be every 2 feet on the feeder. So it can be like, or you can customize it as you want. So this is basically a track of power going through, and you have an option to drop power wherever you need. That's basically the busway.
Really cool product, but it was never intentionally designed for EV charging.
You're right. That's correct.
From the beginning. But then you thought, okay, so many different businesses, I don't know, just FedEx warehouses, I'm making up stuff, already have this type of system, and they need to add EVs to their fleets. So how did this idea come about?
That's right. So EV busway has been around for like, not the EV busway, just the busway has been around for like 60 years. Eaton has been making this for 60 years. We've rolled out probably hundreds of thousands of miles of busway, which is out there powering very critical applications like hospitals, more recently data centers and things like that. It's been out there, right? So it's a natural evolution where we say, hey, we have EV chargers coming out, and then we have this cool way of distributing power, so why don't we just put an EV charger in a busway? It's a very natural evolution for us, and it's one of those innovations we came up with, and it was very well received, especially the instances you're talking about, right? If you're talking about an industrial setting or a last mile delivery, especially where people, like, the trucks would roll in, they would load their packages. While they're loading their packages, they want to charge their EVs and be on their way. For a situation like that, EV busway is very, very efficient and critical. So
what are we looking at up here then? So we have a box all the way on the right. So is that the power source for the busway?
That is not a source. It's just a plug. The bigger box that you're seeing is just coming through. The track is coming through. But in a true installation, you would still have like power coming from some kind of a circuit breaker upstream, and then your tracks are coming through, right? So. And then the smaller boxes that you're seeing with the red sticker on them, those are the EV charger bus plugs. So those bus plugs have a 19.2 kilowatt AC level 2 charger built in. They also have a 200 amp circuit breaker built in. So the circuit protection for the EV charger is built into the bus plug itself.
So you literally just slap it on.
Everything together, that bus plug. Wow. So yeah, you have the track going on. So the way it works is the black tap-off points that I talked about. Wherever you want your charging spot, you would just go in there, plug the bus plug in, lock it into place, you're good to go.
Wow, that is so cool. And because there's already an existing infrastructure of this, you have an instant client base, which is really cool.
That is correct, right? So yeah, if they have an existing bus way already laid out, the feeders already laid out, all they need is bus plugs. If they do not, then yeah, they can run the bus plugs. And that is where the scalability aspect of this bus plug comes into play, right? A lot of customers that we are talking to, they have a 3 to 5 year ramp up plan. They're not buying all their EVs the first year. They're probably buying 5 or 6 this year, probably 10 next year. So in situations like that, you can have a bus way laid out. And for instance, if the bus way, the conductors inside can go all the way up to 5,000 amps. So,
oh wow, really?
Yeah, okay. Really high amperage, right? So even if you take a 4,000 amp busway laid out, you can have up to 60 80 amp chargers on that busway once it's properly laid out, right? So, and this also considers phase balancing. So you have 3 phases. You want to make sure you're not loading one phase versus the other. So you can place chargers so that you're taking care of the phase balancing also. And once you have the busway laid out, you have 5 trucks this year, you buy 5 bus plugs, log them in, and then you're ready to go. Next year you have 5 more trucks come in.
Yep.
You don't have to do anything. You just order 5 more bus plugs, you plug it in, ready to go. So from a disruption standpoint, it's very minimal.
Yeah, that is so cool. Yeah. And I love so the cable management can be done however you want, but still you're at the 25 feet maximum.
That is correct. That still continues to be the constraint of the NEC, but then there are other ways to increase the length, but typically the ceiling is long. I mean, it's in a right spot where the 25 foot is good enough. And there are multiple ways to do cable management. We provide this, but there are other ways to do cable management. That is not a limitation. You can have motorized cable management. You can have all kinds of things.
Yeah.
But then the thing is, everything is overhead, right? Yeah. So typically when you let it go, if you see that cord, it's about 6 to 7 feet high in the air. So nothing is on the floor. Right. So when drivers drive in, drive out, they're not hitting anything, they're not damaging anything. That is one of the things that we hear from our customers is, one, we don't want to give up our parking spot for EV chargers.
Right.
We don't want to dig or trench. That is a very expensive process.
Yeah,
we don't want to do that.
Yeah.
And then two, the trip hazards of this thing lying on the floor, somebody falling and becoming a liability. So all of these things are solved with the solution where you have a completely overhead solution with cable management incorporated in it.
Yeah, I love how industrial it is. It's not meant to be beautiful. It's just meant to work.
It's just meant to work, and it's meant to scale up, right?
Yeah.
So that is the thing: the flexibility, the scalability, and the serviceability. One of the charges down, if you have a bus plug lying down, all you need is an electrician. I mean, you just turn the power off, plug it in, lock it in, you're ready to go.
Dang.
So from a serviceability standpoint, your downtime is going to be really, really minimal.
And so, like this. You mentioned 5,000 amps through these. So
correct.
This thing can handle all the charging you can want. And to be honest, most vehicles probably don't need 80 amps all the time. So you're not really going to be maxing this thing out, even with 100 chargers.
That is correct. That is correct. So yeah, so with dynamic load management, with plug-in charge capabilities that will be coming out, these can support plug-in charge. So you can have a facility that is super smart, trying to see, hey, where you need to charge, where you need to back off. So
cool.
That's the same theme we're talking about. Hey, we want to put out products that think about power management, that think about the grid, that want to make sure you're peak shaving where you need to, and keep the customer's electricity bill low.
Well, this is what I want to install at the hub. So it would be really cool just to do one across the roof and have like 3 hanging down or something.
That'd be
awesome.
That'd
just
be
as
great.
a showcase. So anyway, thank you so much for the tour on this one. This is a really cool product. Guys, more importantly than just charging is, of course, managing all of the charging from the software side. So this would be like a load management and access control, making sure that things are up and running. So yeah, I'm just looking at this really for the first time. There's a bunch of stuff going on here. Maybe you could explain it for us.
Yeah, so what you're seeing here is the Eaton Charge Network Management software. This is a dashboard. Has a number of widgets on it to help you see what's going on with your implementation, right? So top left, you've got a bar that shows the status of all the stations in real time. This just happens to be for this single location, but if you adjust this and you want to look at all the locations, it'll adjust in real time to cover all of the stations across all of the Eaton production sites.
Yeah. Okay. Dang. Lots of power going through.
Yeah. So there's a lot going on there. If we come back to Warrendale, the next widget over is just a tabular listing of how many sessions have happened. It's early in September here, so there's not that many. The amount of power distributed and the amount of revenue. We don't collect revenue at this site. Below that is a histogram that gives you sessions, energy used, and fees collected. So this gives you a sort of a trend over a year. And then below that, you've got all the session level information. Okay, so every time a session happens, you can see what kind of authentication it is, whether it came from the driver app or from an RFID. All of this information, both in the histogram and in the tabular listing here, are exportable into CSV. So if you want to put those into some other system, for example, if you wanted to report carbon credits in California, it'll give you the outputs in kilowatt hours that you need to then give to CARB to get your credits. As you move down the list of things, right? Everyone wants really 4 things out of a charge management system. They want a dashboard so they know what's going on. They want some access control potentially. They might want to collect fees, and they want some load management, right? Those are really the 4 things that software does for you. There are other things that other people do. Most customers don't use them, okay? So Up here, we can look at pricing. We support a wide range of pricing policies. They can vary by charge station. We can do discount structures. So if you've got a certain number of drivers that you want to give a discount to, maybe you've got an employee discount, and then you've got your stations that are open to the public. You might want to give your employees something like 50% off or free completely. In terms of pricing policies, we can go and create a new pricing policy here. And this allows you to give it a name, and then you can select the charges you want it to apply to. So pretty straightforward. You can do freeze, you can do time of use, you can do tiered pricing. All of those are pretty straightforward. Most everyone does those things, okay? We also have the ability to put idle fees on station. So once charging is complete, you want people to move.
$1,000 a minute.
Yeah. So that's the stick option as opposed to the carrot, right?
Yeah, exactly. Yeah, I'm all about massive idle fees. I want minimum $1,000 a minute.
Yeah, believe me, that's really the only way to get people to move. The problem is that I've seen too many times where someone just unplugs the cable.
Totally.
And then just leaves it, plugged into the holster or on the ground.
Yeah.
And walks off.
So many times. That's literally all of Las Vegas at hotels and everything. Yeah. I just don't plug in.
Exactly. Access control, again, very simple. This is user-based access control. So you can designate the charge stations you want access controlled, and then the people that can access the stations, you can either do that by individual, or we also support email domains. So in this case, you can see out here at the end, it says @eaton.com. That means that anybody that signs in with an eaton.com email address has automatic access to those stations, okay? Power management, we don't have power management enabled here. So let's look at the PSEC in Houston. And so in this case, we've got it set up so that it's a 100 amp, 180 amp system with 144 amps available. And right now you've only got the one charge station that's being charged.
So they're getting full power.
So they're getting full power. As you add stations, the power will, once you hit the peak number, the power will scale relative to the maximum power of the station. So an 80 amp station and a 32 amp station, the 80 amp station will get more amps relative to the proportion of it relative to the 32 amp station. We also have the ability to have reserved load. So if you have this in a garage and you got a lighting system, you can say my lighting system is, I don't know, how many amps that is, and it pops out here. Okay, so that just basically isolates that or reserves that load.
Right, so then you can derate based off of, basically not factoring in that load. You would just have to have a block there.
Yeah.
And is it possible to do load sharing on the DC side as well?
Load sharing on the DC side is not available today. We're looking at it. The applications for DC are typically, fueling station type models where you want to get as much power into the vehicle as possible. And so it's not a priority for us to do that. It's not an OCPP limitation. OCPP is fine to do it, but it's a question of the testing and all that kind of stuff that needs to happen.
What about load sharing with non-Eaton chargers? Can this integrate other types of chargers, or is this if you just have an Eaton situation?
So these are this is the charger dashboard. If we want to go in and add chargers, right? This can support a broad range. Oops, let's see if I can do it.
Yeah.
I'm not sure if I can. Yeah. So you can see there's a broad range of charge stations that are actually supported with this. So this can be used to manage a broad range, right? Cool. Both AC and DC.
Yep. So that's great, because I know you might come into a lot of buildings or people that want to add Eaton chargers, level 2 chargers, busway chargers, whatever it is. They may have other branded EVSEs around, so it'd be cool to load manage all of them.
Yeah, exactly. So as long as those charge stations support load management using standard OCPP charge profile type commands, this system will enable it.
Very cool. That's
and
awesome.
We do a lot of testing in the background on this to make sure that we're compatible with all those,
amazing
systems. The one thing that Eaton does that's maybe different is that we do a whole heck of a lot more security, cybersecurity testing than anyone else does.
Okay.
And so, our stuff, whenever we ship out firmware, it has to go through a very rigorous review, and if there's any issues, we won't issue it. The other thing is with cybersecurity is that we do continuous testing. So even after software is out there and stations are out there in the field, we're looking at those legacy versions of firmware against emerging threats, so that if we encounter something, then we can issue fixes to solve those problems.
Nice. So this will get over-the-air updates to not only the EVSEs, but also the software backend for security purposes.
Correct.
Which is cool. I've seen a lot of CMS systems or charger network management systems, as you described this one as, and I've never seen any company really even mention cybersecurity to me.
Eaton is very high on cybersecurity. That's one of the calling cards that we have, is that you can be sure that it's not only secure when it leaves the building, but it's going to be secure for the life of the product.
Amazing, cool. And this is where I imagine you can also configure access controls, set up new RFID cards, set up new payment plans, stuff like that.
Yeah, correct. So the pricing is the payment plans are in pricing.
Yep.
Access control is here. RFIDs are free, so you can go to the website, order an RFID, it'll be mailed to you. It comes in a 2-piece break apart, key fob and credit card form factor.
Yeah.
And then you just register it with your personal account.
Okay.
Right? So the driver owns that. You can, down here, if you want to just have vehicles, like we've got here, is we've taken some of these RFIDs and we've put them against specific vehicles. So, you know, when we got a fleet vehicle outside, on the keychain, they've got a fob. And that way we know that when that guy plugs in and uses that key fob, it's that car,
it's the
right?
key or whatever it is.
It's not a perfect fleet vehicle identification. We're not going to have that until ISO 15118 is complete.
Yeah, sure.
And available. But it's a step in the right direction.
Yeah, we've seen just the beginning level 2 stations do 15118, you know, sort of access management, or I should say like certificate exchange for level 2. It's common in DC now.
Yeah.
But coming to AC.
Yeah, and the stations you saw outside are 15118 ready.
Okay.
As soon as the vehicles are really there.
Of course. No, well, thank you so much for the tour of this. This is super cool. Just as important as the hardware, of course, and maybe even more important is your side, the software, to make sure it all works.
It's all about the use case, right? The customer, the customer, the customer.
Yeah, amazing. So, well, thanks for the tour, and I'm sure more to play around with this at some point in the future.
Yep.
Guys, this is my friend Mark from the eMobility Group inside Eaton. Thank you so much for joining.
Great to have you.
And it was a happy coincidence that you happened to be here.
It was, yeah. I was here supporting our partners in the breaker team for the electrical sector, and so that I'd stop by and talk about the eMobility Group within Eaton.
Yeah, so we are, of course, focusing on charging in this video, but Eaton's so huge, as we mentioned 50 times in this video already. You are really involved on the car side of things.
That's right. So Eaton has a legacy as an automotive supplier, from all the way to engine valves, superchargers, torque differentials, transmissions on commercial vehicles. And so we've kind of married that with our electrical side of the business and formed the eMobility Group. So that includes a lot of our circuit protection devices like EV fuses, our product called BrakeTor, which I'll talk a little bit more about in a second. And we also do traction inverters and bus bars and connectors and things like that. And basically anything electrical under the hood, you know, we have some part to play in it.
And pretty much any one of our viewers who has an EV probably has some Eaton in their vehicle.
Yeah, that's right. So we have a lot of EV fuse content in the market right now. We're one of the major players. So we're standing in front of an F-150 Lightning. This contains quite a few Eaton EV fuses. So we have 400 and 800 volt fuses. I guess they're technically 500 and 1000 volt fuses.
Sure.
But yeah, we're quite big in that segment and quite proud of our technology and the fast clearing protection that it provides.
So BrakeTor is something interesting. We had dinner last night. We were talking a little bit about it as well. But we were talking, if you crash an electric car, just as an example, there's many other uses for this. But the biggest thing I know is I have a lot of friends that like rebuild broken Teslas and stuff. Anytime the airbag goes, the pyro fuse goes in the battery. And then it has to literally be taken out, new fuse.
Yeah, so typically when you're designing the electrical architecture of an EV, you're looking for passive protection, the ability for the vehicle to shut itself down and protect in the case of an event. And then there's also active protection. So a pyro gives you active protection. It has to be triggered by a computer on board the vehicle. So it's also directly tied into the airbags on the vehicle. So obviously that's a very safe thing to do, but it does lead to a service requirement. So BrakeTor is a unique product that it combines the best elements of a thermal fuse, the passive protection that it provides you, and the active protection that you get from a pyro fuse into a single device that can also do normal operations on-off switching. So it gives you coordination. We talked a little bit about this, where if you're driving a performance vehicle where you really want to draw lots of power, like over 1,000 amps for your quarter-mile times, and you're relying on a thermal fuse to provide that protection, it gets very big very quickly, because you don't want what's called a nuisance fault, where you're at the end of your quarter-mile run and your car just shuts off because your fuse popped, right? But then what that leads to is that you now have to size your traditional contactors very large to pair with that, and in order to survive until that fuse clears. So BrakeTor, by kind of mixing all of these elements together, and it's really heavily based on our circuit breaker technology that you see in DC and AC applications, into a single device, lets you drive at crazy high power levels for short periods of time, but also have this coordinated protection and the ultimate safety. And then the ultimate kicker is that, unlike a pyro fuse, it's resettable.
Yep.
So if your airbag goes off, you're disabled, but you can reflash, or the dealership can log in, or you can have a limp home mode. The OEMs can kind of choose what their warranty or their repair strategy would be, and it will at least get you somewhere else to or without having to open the battery pack to get the car back on the road.
Yeah, and if it gets serviced and it looks like, oh, the battery wasn't involved, you can just go, oh,
that's exactly right. Yep.
Rock and roll.
Yep.
That's so cool. I mean, there's so many different uses, and we'll do a video on that. I think we've actually seen this in one of our videos at some point. Maybe it was
potentially, yeah. When you've done some tours of our booths.
Yeah.
That's a great place to come and see all of the products that we have. We have a big, it's like a fake car laid out with all of our products in it, and so inquire more, reach out to me or through Kyle, and we can talk more about how BrakeTor could help in some EV applications.
Yeah, especially as I like high performance EVs, but also safety. So
that's right.
This is a cool technology.
Yeah, so and the first applications of it are going to be in some performance-oriented EVs coming out later this year. So early next year, and before the end of 2024, you'll be able to buy a car with BrakeTor on the road.
Hell yeah, that's awesome. Well, thank you so much.
Thank you so much.
You joining.
I hope you enjoy the tour.
Yeah, this is so cool, and it's really hard to give our viewers a scale of what the heck Eaton does.
Yeah,
because it's just insane.
Well, I've worked here for 10 years, and it still surprises me.
Amazing. Well, thanks so much for joining.
Thanks.
Well, guys, holy smokes, lots of information in this video and so much more to explore. I mean, just the topic of power, how we distribute it, how we use it. This is all really fascinating and will be the basis of a new channel coming at some point in the future. But with that said, I wanted to leave you now with the F-150 Lightning charging on the busway overhead. We learned so much about AC charging and DC charging, the future really Eaton getting into the DC charging game, but a lot more cool stories to come. Really neat AC charging solutions, many of which you can just put in your own home. I'll leave all the proper links, so if you saw an item that you really wanted to purchase, that'll be down there. But of course, this was a great educational piece, a great way for me to learn and soak up with many experts today. Just so much information. I really love the breaker EVSE, where you don't need to buy this big expensive wall box. You just plug it into your breaker panel, charge a car. To me, that's magic. This busway situation is complete magic as well for fleet situations, and I think will be perfect actually for our hub. I really would like to get this installed there. And well, there you have it, the Eaton Experience Center in Pittsburgh. We learned a ton about software, hardware, and some really big hardware. And I can't thank you enough for joining me and watching this video. This was really epic. So thanks again. We'll see you on another one again soon. Bye-bye.